part 2, and we're going to talk about finding roots of complex numbers in trig form. Before we go there, let's talk about a square root of 4, and it's probably not a stretch for you to know that there are two answers, because 2 times 2 is 4, and so is negative 2 times negative 2. So there are two solutions. How about the cube root of 8? The cube root of 8 is some number. When you multiply it times itself 3 times, it comes out to 8. So another one that you should be able to get. So I know this is what's going on in my thoughts. 2 times 2 times 2 is 8. So the cube root of 8 must be 2. All right. So the thing was, we were telling you the whole story back here. But when we got to here, we haven't told you the whole story. Actually, just like every square root has 2 answers, cube roots have 3 answers. And fourth roots have 4 answers, and fifth roots have 5 answers. So we've only told you part of the story, and that's because the other 2 answers to this problem are in the complex plane, and you weren't able to bear it, but now you are. So let's look at an example, and I'll show you how this comes about. Suppose I want 8 cosine 36 plus I sine 36, and I want to find the cube roots of that. So as I promised, there are more than one. So look at this. Let's take 2 cosine 132 plus I sine 132 and multiply that times itself 3 times. So we learned how to do that first part of this video. So if you raise that to the third, recall that you raise that to the third, we're going to get 8, and then multiply that times 3. And we multiply 132 times 3, we get, 396. And we reduce that when it's over 360. That means we went around 360 and a bit more. So we can reduce that by subtracting 360, and it leaves us 36. So this is equal to 8 cosine 36 plus I sine 36, proving that this number up here is a cube root of this. Alright, so this is a cube root, so I'll write it up there. 2 cosine 132 plus I sine 132. There's actually a short hand for that, but I'm not going to tell you what it is. Not today. Alright, so the cube root is that because I could show that when I multiply that number times itself 3 times, it gets me what I started from. And there's the more obvious one. Let's try that one. They don't have to be in any certain order. Let's try 2 cosine 12. I sine 12. 2 cosine 12 plus I sine 12. And when I do that and raise it to the third, do I get back to my original problem? Raise 2 to the 3 and get 8. 12 times 3 is 36. So there's another cube root. Now I haven't taught you how to get them, but I'm just showing you that they are cube roots. So this got back to that, so that means this is a cube root. I'll put it in my list up here. Should have done this one first, probably, but it's fine. Alright, and I promised there was a third one, so I was wondering if this might not be it. 2 cosine 150 252 plus I sine 252. All right, and I'm going to cube that and see what I get. So I raise the 2 to the 3 and I get the 8, and I multiply 3 times 252, and what does that give me? 756. All right, so let's reduce that. That's more than twice around. Twice around is 720. And let me check, 252 times 3, 756. So when I subtract 720, I get 36. So really this is just the same as my problem right there. So I got the original problem that was under the radical. So this must be also a cube root. And I promise there were 3. You can look for a while and you won't find any more. But there are 3 cube roots, and they're all in the complex plane. And we'll do more with this, but I think I'll show you how to get those. And it's sort of a part 1 on this, but that's all we're going to do for today or this evening. All right, if I graph those 3 answers on the unit circle, I have 2 cosine. I'll do the 12 one first. So say that's not the unit circle, forgive me, because it's going to be 2. The modulus is 2, so it's going to be 2 away. So on the complex plane, we're going to go 2 away. Let's say that this is a circle with radius 2 instead of a unit circle. So that's fine. So the 12 is 12 degrees from the first, or the simplest answer, would give us this amount of distance at 12 degrees. And so we'll say this is 12 degrees. And the second one was 132. So 132 is going to end up somewhere about here. And 252 is down here. And it turns out that that is a pattern. And if I was doing 4th roots and graphing them as well, say if one was here, the other would be here, and like that. And if I was doing 5th roots and then graphing them, and say one was here, one would be here, 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 and here. Like, how do I know so quickly where they would be? Because they're always the same degree away from one another. So when it's 3rd roots, I'm going to take 360 and divide it by 3 and get 120. The difference between this one and this one is 120 degrees, and this one and this one, 120 degrees, and this one and this one, 120 degrees. So it's always 360 divided by the root. I'll call the root n. Over here, if I knew this first one, I know, because I'm doing 4th roots, the distance between each one is going to be 360 divided by 4, which is 90. So the difference between here and here is 90, 90, and 90. And like if I was doing 5th roots, I would take 360 and divide it by 5. And what is that? Let's see. I don't have my... Is it 72? So if I knew this one, it would be 72 more, 72 more, 72, 72. And I could get back to the original. All right, so with that in mind, I can find the answers quite quickly. So again, pretend you can't see all this work, and we're starting the problem right there. First of all, you would take the root of the modulus, so the cube root of 8 is 2, and you would take the cosine of 36 and divide it by the root, and the root is 3, so we get the first answer, and it's 12. So we get the 12 answer. I'm not going to write it all out. I'll just write it like that. And then from there, to get the next one, we look at the special number that we discovered down here. We always are going to add 120 for cube roots. So when I add 120 to the 12, I'm going to get 120, 132. And then I'm going to add 120 again. And I'm going to get, when I add 120 to that, I get 2 cosine 252 plus I sine 252. Oops, need a 2 in there. So anyway, I wanted to introduce you to that quickly. We're going to do more with it, but you can see a little bit about how these relate to one another. Patterns, patterns, patterns. That's about all there is in mathematics. Alright, so I will show you more and get you confident in doing these problems in class. It won't take me long to show you a few examples and get you there. Have a good rest of your evening. Goodbye for now.